Hello, today we are going to build the internal tangent to two disjoint circle, and this picture just gives us an idea of where we are going and what we're trying to do. So let's get started. First, we start with our two disjoint circles. And now we want to draw the line segment. Next, we want to draw the circle through AC, and we can find the midpoint of AC and then draw that circle, or we can just use the circle tab. And since I only want one side of the circle, I will use the semicircle button. Now I have the semicircle through A and C. Next, I want to draw the circles with the radius the sum of our two radii. And first we have to label our radii to find what they are. So this is H, we can see it here, and this one is G. So we come down here and we write equal G plus H. And that gives us 6.57. So we want to draw the circles centered at A with radius 6.57 because that's the distance of both radii. Now that we have that, we want to label the intersect here, and we can choose intersect or just choose point. I personally like to choose point because it's easier and it still select the intersect. And now we want to draw the line segment AE and label the intersect of that with our original circle. Now that we can draw the tangent to A through the bigger circle. The key point here is to know that because it's a common internal tangent, it will be perpendicular to our two radii. And if one line is perpendicular to the two radii, that means the two radii have to be parallel. So I want to find the line segment parallel to AF through point C and label that intersection. And line segment, now we have our internal tangent. We are not done. The next thing to do will be to find the formula of the distance of the internal tangent in terms of the distance between the two centers of our circles and the radii. First, let's hide everything we don't need to make our life easier. We don't need this, we don't need this, and this. Command G, and because I also want to hide point E, I will segmentize line segment AF and go back and select point E and E. Oh. Let's draw our line segment CG. It will be easier to find this by drawing the rectangle with side AF and FG. To do that, we are going in the circle tab and select compass. So we want to draw a circle at G, segment GF, so we can add it to our original length. And we are just gonna draw the line segment CJ there and label this intersect. Again, we're gonna hide what we don't need. And I will segmentize GH. So then now we can hide what we don't need. And join point A and H. Now we have triangle, rectangle AFGH. And because it's a rectangle, that means we have a right angle here. So we can therefore use the Pythagorean theorem on triangle ACH. Let's do that on another tab. Nope, I do not want it. Okay, so bear with me. Because we know AFGH is a rectangle, we can therefore say that this is a right angle, and if this is a right angle, we can consider the right triangle ACH and say that AC squared. Oh boy, this is not right. Well, we are keeping it in GeoGebra. We are going to use the text tab. I didn't want to use it because it's just too tedious, but we're gonna have to do it. And we want to enter a text here. So now we are saying that AC squared, AC, we go on symbol, latex formula, and then roots and fraction to select the squared. So now we know AC squared is equal to AH squared plus HC squared. That's using the Pythagorean theorem. So we know this. And from this, we can solve this for AH. So then we get AH squared told you guys this is really tedious. We get AH squared is equal to AC squared minus hc squared. And AC squared is the distance between AC squared is the distance between the two centers of the circle, and HC squared is just the distance of the big radii, the radii of the big circle added to the radii of the small circle. So we're saying that AH is equal to AC squared minus HC squared. And we can check that right now given our values in GeoGebra. So from GeoGebra, we know that, let's go on select first so that we can select things. We know that AH squared, which is this, AH squared is equal to 9.51. No, AH is equal to 9.51. And AC squared is equal to 11.56. And HC 4. HG is 4.29 and GC is 2.29. So if we do the algebra here, in even using our calculator, we will see that AC squared minus the sum of the two radii squared is indeed equal to the square of the distance between the internal tangent. And I say it's the distance between the internal tangent because this is a rectangle, therefore AH squared is equal to FG squared. So that gives us our formula. So we can then say that, one more text. So we can then say that FG squared, which is our actual internal tangent, FG squared, I think I'm just going to copy this and paste. FG squared is equal to AC squared minus, let's just add the distance between the two radii, AF plus GC plus square. And this is the formula that we want, that we're interested in. Thanks for listening.